Alright, welcome everyone. In this video, we're talking about prime numbers. Since ancient times, prime numbers have captured human interest. Still, they have remained notoriously elusive. Prime numbers are one of the simplest, yet most complicated topics of math. Questions related to primes are often so difficult. Prime numbers are the positive integers having exactly two positive integer factors, 1 and the number itself. For example, the number 7 has only two factors, 1 and 7, so we say that 7 is a prime number. Another way of defining it is that prime numbers are the numbers which are only divisible by 1 and the number itself. For the number 7, it's only divisible by 1 and 7. Composite numbers are the positive integers having more than two factors. For example, 21 has four factors, 1, 21, 7, and 3. Likewise, a composite number is a positive integer that has at least one divisor other than 1 in itself. As you can see, 21 has four divisors. Note that the definitions of a prime and composite numbers don't allow one to be a prime or composite number. 1 has only one factor, namely 1. 1 is neither prime nor composite. Every positive integer is composite, prime, or the unit 1. To find prime numbers up to 100, we use an ancient algorithm. First, make a chart of the first 100 positive integers. Then, cross out 1, since it's not prime. Circle 2, the first prime, and then cross out every multiple of 2. In other words, every second number. Circle 3, the next prime, and then cross out every multiple of 3, or every third number. Some numbers like 12 may have already been crossed out, since they are multiples of 2. Circle 5, the next prime, and then cross out every multiple of 5, or every fifth number. Continue this process until all the numbers 1 through 100 have either been circled or crossed out. Now we circled all the primes from 1 to 100. This short list of prime numbers can already reveal a few interesting observations. Except for the number 2, all prime numbers are odd, since any other even number is at least divisible by 2 besides 1 in itself, which makes them composite. Except for 2 and 5, all prime numbers end in the digit 1, 3, 7, or 9. In each of the first and second groups of 10 numbers, meaning between 1 and 10 and 11 and 20, there are 4 prime numbers, while in the third group of 10, meaning between 21 and 30, there are 2 primes. Prime numbers become less frequent as we go on. Throughout the history of math, the greatest minds have tried to prove a theorem for predicting which numbers are prime or how prime numbers are spaced out. One of the interesting aspects about primes is their distribution among the natural numbers. Is it random, or does it follow a pattern? So far, primes have resisted many formulas and equations. Prime numbers are infinite, and this could be proven by the classical Euclid proof. Assume there is a list of a finite number of primes, the smallest being p1 and the largest being pn. Consider the number n, that is the product of these primes, plus 1. By construction, n is not divisible by any of the primes on the list. Then n would either itself be a prime number not on our list, or would be divisible by another prime number not on our list either, contradicting the assumption. For example, if our list of primes is 2, 3, and 5, so the number n equals 2 times 3 times 5 plus 1, this is 31, which is a prime number not on the list. Another example, if our list of primes is 2, 3, 5, 7, 11, and 13, so the number n equals the product of these primes plus 1, This is 30,031. That equals 59 times 509. This makes the number n divisible by 59 and 509, which are two primes, not on the list. Significance of prime numbers in both daily life applications and as a subtopic related to many branches of math can't be exaggerated. You can consider prime numbers as being the building blocks from which every natural number greater than 1 is made. The account of prime numbers is still surrounded with mystery. The story isn't finished at this point.